Okay, I will start by doing this, my friend. I would like to show you this is the last few years question that came out in planning. At the start, planning used to be in paper two. That's why paper two was hell. It was tough enough. They put the planning inside there. Super cannot finish the paper one. So everyone, I told them 10 years ago, right? Skip the planning, don't do later, then come back. People don't heed the advice. They spend half an hour on the planning. Silly. All right. Some people just don't want to listen. Sorry, straight to the point. It's going to suck up the time. Why? And it's so tough to get 3/4 of the marks or full marks. All right. So, but in 2017, it became planning part of the practical, your paper four. So it become more legit. Okay. In 2017, it came out with a kinetics question. So for 14 marks, determine the effect of temperature on the rate of decomposition of H2O2 with catalase and the enzyme. Yes, the catalyzed reaction. They ask you to plot using a design with a graph of ln k prime versus 1 over t. And the whole idea, the aim of the experiment is to determine the values of activation energy and A, which is the Arrhenius constant, using the Arrhenius equation and a sketch of the graph, a sketch graph. Was it tough? Tough. Okay, kinetics one, always tough. They're planning. I'll just run it here first. 2018, the energetics. Determine the maximum temperature change, delta T max, graphically for reaction between copper 2 sulfate and zinc powder. So what is this? This is metal displacement reaction. It's a chemical reaction. There's bond break, bond form, whatnot. So there's energy transfer. So apparently it's exothermic. So they ask you to determine the maximum temperature change. So very simple. Right? Create a table, draw a table, initial temperature, then the highest temperature. So there's some change in maximum temperature. And plot a graph of T versus time, how it look like. Okay, which you should be able to comprehend. Easier. So it's energetics. 2019, go back to kinetics. This time around 8 marks. Collect sufficient data to allow a graph of volume of thiosulfate against time to be drawn. And you all know thiosulfate experiment is always what? The one we just discussed yesterday, iodometric. Can see everyone? So you need to know that equation that you're supposed to write out and then present your answers. All right? And you should follow a certain shape, where by the end, then you say what is the order reaction and likely what is the rate equation. Okay? For 8 marks. 2020, organic chemistry came out, which is plan a procedure for the preparation of 10 grams of pure and dry nitrobenzene, starting from benzene. You know what? That few years, when it transferred from your paper 2 to paper 4, everyone said procedure won't come out. Crazy. It has every chance to come out. And 2020, so many one was crying. Everybody thought energetics, thought kinetics, planning. Zero. Do you agree with me? This is so simple. It's damn 12 marks. I use the word damn. Plan a procedure for preparation of pure dry nitrobenzene. Remember what you do, my friend? Isn't this theory? All you need to know is what you need over there, correct? Your reagent condition. And you know what size beaker to use or not, correct? Use the one that's in your lab. You should know the standard sizing of apparatus. So remember this one? And it was 2020. How long never come out, my friend? Right? 5 years. Will it come out again? I never know. Right? But we all know, right? Remember this or not? So benzene, what do? You get your nitration, remember now, my friend? Correct? And then you write this. So you write all the thing, but in more detailed manner, correct or not? Then you liberate now, correct? That's the question. Damn. Really damn. It's easy. You can't do the mole, you write the procedure already, half the marks, at least 6 already, I'm pretty sure. Make sense? At the end, how to clean it up, blah, blah, blah. So good. Correct or not? You write your standard reagent condition, they're going to give you some marks already. Oh, they don't even come here, all right? For preparation of pure dry. No, I was wrong. Not even here. It's nitrobenzene just here. Not that difficult. Yeah. Then you draw one equation for them. Tell them this is how, because they do more calculation. Do you know what's the balance equation for this? Yes? The nitration equation? The equation is 4 mark. Can see now, my friend? Because the equation shows the molar ratio. And your job is what? 10 gram of pure dry. Okay, 10 gram. Right? You know the MR, you calculate the mole. This is already 1 mark, if not half a mark. Agree with me? Then use the balance equation. You then say how many moles is required there. Maybe together there's 1 mark, if not 2 marks. Make sense? You know the MR? And of course, you calculate the mass. Correct? Benzene is a solid, if not a liquid. Make sense? Correct? Then can you weigh them? Can you volume them? Yes, my friend. Can you see not? All the marks are there. Check your revision package. Your school should have given you at least one on organic chem synthesis. And likely is this one. All right, go and take a look. Proposed by your school. Or don't bother get other school, what school doesn't matter. All right. Some school give so much that in exam, their student also cannot replicate also. It's just a waste of effort. All right. Just use whatever your school give you. All right. That's it. Use it. Don't bother about other school stuff. It's just a waste of time. All right. Who's the longest the ranking JC few years back? YIJC, right? Straight to the point, right? My student also get A, what? So what? So the top school is what, RI. How many students in RI get A for H2 Chem? Yeah, quite substantial amount. But most also don't get what? Same thing, what, everyone. So just use your school notes. It's good enough. All right. I don't care which school you're from. All right. Make sure you can do the fundamentals. Can I? Oh, basic mole calculation and then what? Safety issue, of course. Organic chem, correct planning what you write, they usually are what? Correct? Usually organic compounds are volatile. Make sense? So, oh, correct now. Then you write something about that. Then sometimes they are also toxic, right? It's always the same 2, 3 bullet points, just throw in. Correct? Just throw them in. They ask you for safety issue precaution. Just throw them in. Okay? 2021, gravimetry came out. So every year a bit different. Plan an experiment investigation to determine the value of X in sodium carbonate. Ladies and gentlemen, we did the practical experimental technique. You should know how to do, yes? So replicate the one they give you, throw inside there on 9 marks. Right? That's it. That's it. Done. All right. Replicate the table, everything all in. Done. That's your 9 marks. Write 2 A4 pages of bullet points, tables, maybe with a diagram. Okay, done. Kinetics back again. 2022. Describe how to make 75 cm of a solution of phenol of approximately concentration 0.01 mole per unit and state any safety precaution. Again, can you see? Once you touch organic, always for safety precaution. All right, go and remember the 2, 3 liner. Come on, just whack. You get it 1 mark. How you make 75 cm of solution of phenol of this concentration? You know how to do? So you did describe how to make this solution. All right, so the volume is fixed 75 cm3. Right? So you need to know how many mole. How to find the mole? You have the MR, so you need this mole, right? Back calculate, you know the mass. All right? So you're going to measure using a weighing boat or whatever. Done. Graph of ln 1 over T versus 1, ln 1 T versus 1 over T, time versus the temperature. And after that, a very common, then determine the value of EA. Everyone can write a note there, and I think it's always tough. I want you to go and check your school revision packages because it's tough. Yes. The kinetics one, whenever you talk about EA, all the activation energy, all right, go and take a look. It won't be that many. Okay, all the activation energy, all the EA one examples, right? Planning question EA, go and mark them out, go and run through once on your own. Okay? Because students usually they're stunned. All these 14 marks. Back to 2023, organic chem is out. 2 years ago, it came out again. Do you see what I see, my friend? That year we were laughing because we talked about it. We didn't spend our time, but we say in our practical we don't do because it's very boring. I say, everyone, up to you. If you're lucky, good for you. If you're unlucky, you swear you'll come out again and haunt you. Like how I tell you, right? How you know you'll come out and won't come out again? When was the last time organic came out? 2020. People say won't come out again one. Practical planning will come out. Congratulations. Ladies and gentlemen, here we go. How many years later? 3 years only. And that year a lot of people cry. Oh, everyone say planning will be what? Rubbish lah. Nobody will know what will come out. Alright, that's it. Done. 14 good marks, my friend. Which means the hands-on less marks. So the more marks on the planning. Plan a procedure for preparation of 6 grams of pure and dry aspirin. Pure and dry. So you must dry at the end. Alright. Aspirin using 2-hydroxybenzoic acid and ethanoic anhydride. Okay, again, the context, the question will give you the equation, I give you the context. Yes? The double count reaction, so don't worry. What is anhydride? So basically it's a condensation reaction if I'm not wrong. Okay, so part of the procedure must be described in the question, which is to prepare 6 grams of this. Basic mole calculation, as I told you, right, is there a few things. Mass, mole, MR. If it involves the volume, then concentration formula. Draw the apparatus for esterification, as I told you. Esterification, you all know use what? Someone use what? How do you esterify? Someone give me the condition for esterification. Go. Wait for you. So these are things we get prepared. Someone esterification, what is your condition? Using what we know best, carboxylic acid and your what is that? Your alcohol. Okay. All right. Corn H2SO catalyst and reflux heating. Is that a temperature? Don't have, right? Have or not? Have, right? I think there's a temperature, right? Have or don't have? Don't have. Can't remember it. Corn H2SO4 as the catalyst reflux heating. All right, you need to do reflux and whatnot. Acyl chloride, don't use acyl chloride. Huh? So not acyl chloride very reactive. So we don't do it through that route. Through your normal route, which is use your catalyst. Also going to revise all this. All right, and at the end, because need to pure and dry, right? Separation techniques and how to purify, determine the purity. How to test purity, assuming it's a solid, test what? Test melting point, no? Correct? That's it. Test the melting point, it should melt at a constant temperature. That's it. And as usual, as I told you, safety and precaution. Once organic, is just whack this safety and precaution in. Okay, remember planning, huh? Okay, so what is this planning? It suggested for 2 marks. It suggested the reaction of iodate 5 and hydrogen sulfide ions when be catalyzed by transition metal ions. Suggests why the reaction between them is slower in the absence of a catalyst. Iodate 5 and hydrogen sulfide. 2 marks is not even planning, it's theory, right? Someone want to tell me the answer? I show you the reaction. Dang, 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 dang. Like, iodate is this thingy, potassium iodate, hydrogen sulfide, sodium is this thingy, which is here. Someone type out the answer. Why you need a catalyst? Go study your theory, my friend. Type it out. My goodness. It's very easy on practical. It's not as difficult as you think. It was bad for you because all this while you never revise. You don't even know your content, you go and take a practical. Of course lah. You built up for 2 years already. What do you want? Alright. You've been running away for too long already, right? High EA due to negatively charged anions repulsion. Of course. Correct. Alright. Negative repel. Correct. Activation any high. So I need a catalyst to come in and do 2-step mechanism. That's it lah. Alright. 2 marks lah. Easy, right? So repulsion 1. Number 2, high EA. 2 marks already. Feel happy now. Must be happy. Before go practical, must be happy. All 3 sciences, okay? Right, I give you 3, 4 lines. You need 2 lines only. Can I run? Okay. Show you actual question. Yeah, talk is cheap. Don't take photo. Don't get me in trouble. Okay. Plan an extension to the investigation 2A. Okay. Now then is the plan. Okay. To test how well 2 different transition metal cations A2 plus and B2 plus catalyze the reaction between iodide between the you do not need to carry out your plan. So no need to do hands-on. You may assume you provided a solution containing this concentration of 2 plus. 2 different ions, maybe iron 2 plus, cobalt 2 plus. Yeah, transition metal, right? Your plan should include 2 further experiments, a table of volumes of solution used, how you will know that the transition metal cations are both catalysts for this reaction. Good question. How you know that the transition metal cations are both catalysts for this reaction? Of course, how I know something is a catalyst? Good question. Because it takes shorter time. Make sense? Whatever reaction, right? It takes shorter time. Again, it's all very, very, sorry, it's the dumb answer. Give them dumb answer. Okay? The one that we normally will write in practical theory paper. Give them very, very simple answer. Don't overthink too much. Okay? How will you know that which transition metal is the better catalyst? Of course. All right? The time. You do not need to rewrite the method given. All right? So, something you can do, add the transition metal in. So, they must be what? They must be aqueous, homogeneous catalyst. Okay? All right? So, go revise a bit. How many marks? I forgot to look at the marks, right? So 2 marks together are 2 plus how many? So of course, 7 marks. Also, the planning is 7 marks. And planning will not always be on its own. So this is attached to a question. Okay? And a small planning. The small planning was 7. So last year planning was a lot of marks. Scary. And this was the one. What a waste, right, everyone? Alama, right? Come on, like organic strong, this is full marks for everyone. Consider 6 organic compounds. All are liquid. Someone tell me it's liquid. Alama. Alright. 6 of them, not 8. Plan an investigation with just testing reaction where you allow you to identify each of the 6 organic compounds. Your plan should include what reagent you add, outline of the sequence of step. The step is just that few marks on it. Usually it's just add and observe, add like heat and observe. Unless it's alkyl halide, alkyl halide. Don't even have alkyl halide. Alkyl halide, then must do more steps, remember? Need to cool it down before. This steps is all the short steps, so easy. Compound can be identified some more, can be a positive or negative test. You should use as a few different tests as possible. You might present your answer in a flowchart or table. Someone tell you can do the way you want it. So flowchart easier or table easier, you decide lah.